Hello, today we are investigating why the test suite of the KDE application Kalk with two Ks, K-A-L-K, this thing, fails. So first of all, I ran kdesrc-build Kalk to build the application, and then I ran the test suite. So kdesrc-build Kalk, no src, no include dependencies, run tests and debug. The result says running test suite, KALK. This is the log file, and make test returned exit status 512. So exit status 0 returned by any process means success, but this process has returned 512, which is error. What can we do next? We can look inside the log file. Where are you? Okay, let's see how that looks like. So it has run gmake test, which gmake is a symlink for make, in the correct directory, which is ~kd/build/kalk. There were 4 tests to run. It failed at test 2, which is k number test. Okay, and it suggests that I run -rerun -failed space -output -on -failure. So this command line is actually not a arguments that need to be added to the command line gmake test. Let's see that. So Ctrl+Shift+T, cd build Kalk. So the command line that actually has exit status 512 and shows this output in the terminal is gmake test. And then it says that we should use these command line parameters, but these command line parameters are not for gmake test. Instead, they're for what gmake test runs, which is ctest. So ctest part of cmake. Okay. So where does it start in here? So ctest rerun failed output on failure. In the correct directory, it knows that out of 4 tests, just test key number test, which is an executable, which exists in tilde/kd/build/kalk/bin/key number test. So it starts this executable and looks at its output, and it stops at the first failure, which is the error. So this is okay, success. This is okay. This is failed. So there's a test that fails when the name of the test is precision greater than or equal to 1000, and then it does key number of 1. So it constructs key number with the parameter 1, and then it constructs key number with this string parameter, calls the addition operator, then to the resulting, I guess, key number object, calls the minus operator, and this is another object of type key number, which was constructed with the argument 1. So we have 2 errors. The first error is that the result is not 1 to the power of So what's this E notation? So it's 1 times 10 at the power minus 980, which is so this thing is 1 times 10 at the power minus 980, which is 1 divided by I think such as this. Okay, so there's 980 zeros. Okay. So should return this number, and if instead it returns 0, and then the result type should be float, and it returns the result. So after it evaluates this entire part, instead of returning a k number of type float, it returns a k number of type integer. That's what the test output says. Errors while running ctest. Okay, let's see what this k number thing is. Let's look first at the source code. So Kalk. Okay. So k number test, probably in here. This thing, k number test. So there's one translation unit which is k number test, which is added as test. It links with a SO named k number or .o file, and the resulting executable is k number test. So let's see this executable file. Build Kalk bin and this thing. Okay, let's actually run it. So that's /bin. Let's put a full path to it. Control A C, Control Shift V. Okay, so it's the same output. In the same place, it fails in the same way. Okay, but then k number test sounds familiar from the KDE application Kalk, which is the calculator. This application. Let's see if Kalk, so with a K and two C's, the other application, has a k number test. Maybe we're lucky. So for that we'll need to build Kalk. K25 KDE Git repositories to clone, make sure they're up to date. Configure cmake, make, which means compile, and then make install to install them in /kde/usr. Okay, let me see why I have changes in Kalk. Let's revert all of these changes. Okay, make sure the local Git repository has a local master branch that points to the same place as the remote origin master, which it does. Now it's clean. Let's build again. Okay, so it's building. Done. Let's look at the source code. So we have the same directory key number. So the KDE community has two Git repositories for two different applications. One is called Kalk with two Ks, and the other is Kalk with a K and two Cs. The first one with two Ks is a QML application using Kirigami Qt Quick Controls 2. And the second one is using Qt widgets. So let's actually run these two and see the difference. So we've built kcalc, now we can run it. How do we do that? This. Okay. Okay, so left-hand side is the application with a shorter name that uses QML. On the right-hand side is the application with a longer name that is written using Qt widgets. Okay, the about dialog is different. These modes are calculator, converter, binary calculator for the QML calculator. For the Qt widgets calculator, there's simple mode, science mode, statistical mode, numeral system mode. Okay, both have history. So let's go square root out of 1 to 1. That's 11. How do we do that in the one with Qt widgets? I'm not sure. 1 to 1 times 2. What did I do? Okay, this is the history and this is the history view. So they're similar but different applications. One is mainly for the KDE Plasma desktop, and the other one is both for KDE Plasma desktop and other form factors such as KDE Plasma mobile smartphone form factor. Okay, and they use KDE frameworks, both applications, and as part of this reusing between do the two applications, the directory key number is somewhat similar. So the two directories are not that up to date. The one from Kalk is at a newer version, and the one from Kalk is at is older. So the files are older in the left hand side than on the right hand side. Okay. So there's the same key number test directory, the same key number test.cpp, which is going to be compiled as the key number test executable, which is actually a CMake test, a C test. Okay, let's see the result of running tests in the left hand side versus the right hand side. Okay, for that we go to the we can go straight to the tilde/kd/build, the name of the application /bin directory, and run key number test from there. Build Kalk bin key number test. Okay. So let's run the one from the left hand side. Okay, it fails where we know it should fail. On the right hand side, it's okay. So it finishes successful. Okay, so we have the same test in two different KDE Git repositories. Once it fails, the other, so it fails for the left hand side and is successful on the right hand side. So what could be the difference between the two tests such that one is successful and one is not? Okay, let's run in the debugger and see, so inspect the line of source code where the error happens. For that I'm using Qt Creator. Okay, I need to open this repository, so file, close all files or projects, file, open file or project, tilde/kd/src calc cmake list.txt, manage kits, keep just the default desktop kit, so remove imported kit, apply, okay, manage kits again, no surprises yet, import existing build, Control V, so this thing should be build. Okay, so since this is a Qt quick application, we'll need to, so the only additional build configuration is debug2, the one that we're going to use. In run, we'll select that we want to run in the debugger key number test, the executable. And then as a run environment, we want the build environment plus the settings for these things. So we prepend to some environment variables, and this prepending is done by the Qt Creator integrated development environment when it actually runs a executable that's built by Qt Creator. Control V. Okay. And now we can run it. Let's see. Okay, and it fails where it should fail. Okay, now let's do the exact same thing for the other calculator. File, close all files and projects, file, open file or project. We need this directory, Control C, Control V, cmakelist.txt, projects, manage kits, remove this strange thing, so we just keep under manual desktop default, remove some more. Okay, import existing build, Control V, replace src with a build. Okay, and then in run, we don't want to run the actual GUI executable, we want to run the key number test. And for the build environment, for Qt widget applications, this setting does not make sense, this setting does not make sense, this setting does not make sense. Maybe it does. LD library path is already set correctly. This is really not needed. So for Qt widget applications, you can run those applications sometimes successfully from Qt Creator without actually editing the projects. Switch to projects mode, Control 5, build and run, imported kit, run, environment, and batch edit. Okay. Let's run this thing. And it has run successfully. Success, exit status 0. Great. Let's have these two things in parallel. The two Qt creators. Okay, and let's go at the affected line. So this is the line that we're looking for. Control C, Control Shift F, Control V. All projects. Search. So line 744. Where is that thing? This thing. Okay. And let's do the same thing here. Control Shift F, Control V, all projects, search. In here it's at a different line, at line 825, because again, these two files are at different places in time. The key number test from Kalk is newer, is formatted differently using clang- format. So the line numbers are not the same. Okay. So let's put a breakpoint before the line. So one breakpoint at line 743, one breakpoint at line 824. Let's close the left sidebar to have more space. Okay. So it's the same thing. A method called testing float precision with one set default float precision 100, one set default float precision 1000, and one set default float precision 20. And in here the same. just formatted differently. This has a mixture of tabs and 4 spaces, whereas this one only uses 4 spaces for indentation. Okay, this strange empty new line. Okay, so let's see if the debugger can take us to the correct lines. Continue. Okay. Continue. So we're at the correct lines in the method testing float precision. What does set default float precision do? I know, F11 to step into. So it does precision, which is the parameter, which is 1000. So it takes 1000, multiplies it with 2 point something, then divides that thing by 0.69. It does a seal from where? Math calls. This is probably the math library. GNU math library, I'm guessing. Okay. So it adds a 1. Seal meaning that it returns an integer. Smallest integral value not less than x. Okay. That's being casted to one side long int. This becomes a unsigned long int with a value 3323. Let's see the same thing in the left hand side. F11, F10. So it's the same 3323. Let's look at the locals view. Okay, so binprec is 3323 in both places. And then it calls mpfr set default precision. Okay, let's step into that. We do not have the CPP file for mpfr set default precision. Let's look at the .h file. So it's in mpfr.h, which is the GNU ampfr library. Okay, which is a library for multi-precision floating point math. Okay. Next. Now we want to be inside of check result. How do we get there? F11, F11. So it took us to a really strange place, into operator parentheses. And then inside of qstatic string data ptr. And now we're inside of qstring constructor. So this is because when we go F11 step into, it actually steps into this constructor, this constructor, this constructor, this constructor, etc. And only hundreds of steps later, it will actually step into check result. Okay, so let's go to the CPP file of check result, control click on check result. It took us to the correct place, key number test.cpp, which is a CPP file from this project that's loaded in Qt Creator DID. So let's put a breakpoint here, check result, breakpoint here. Let's go F10 to step until the next breakpoint. Okay, so we check result, the same thing. Okay, so let's look at the differences. The first parameter is string, which says precision greater than or equals, so they're identical. The two strings, their type is identical. What about result? Let's look at the other ones first. So desired string, the same type, the same value. Desired should be toInt, the same. So now we need to inspect result, which is a complex type. So we'll need to expand it. Result. So these are sort of public getter properties for construction purposes, probably. The important thing is here in detail key number integer. So a pointer named value underscore. But then the type is different. In here it's detail key number underscore float in the correct place. So keycalc is correct. And the type is correct, key number float. Whereas calc is wrong and has the wrong type, detail colon key number integer. So one is integer, the other one is already float. So the precision was already lost, and there's no way the value of result is 0,0000000, okay, which is what's expected as a expected result from this test. Okay, this has a member MPZ, this has a member MPFR with just one element. So they're totally different things. One is MPFR underscore something, the other one is MP underscore limb underscore T. So this MP is actually from the library from GNU GMP, whereas the correct value is from another library from this one, GNU MPFR. So MP is GNU multiple precision arithmetic library, whereas the other one is GNU multiple precision floating point reliable library. Okay. Why does that happen? Well, let's look at why this key number type supports either MPFR or GMP. Let's go to the definition. So this key number does it have a member, a value? Yes, it does. So a backing field, a member value, which is of course private and of type k-number base, which k-number base is an interface which is implemented in two places. How do we find out that? Okay, so k-number integer inherits from k-number base, and k-number float inherits from k-number base. Okay, and the field is named differently. This is named mpfr underscore, which we can see here. I'm in the wrong place. Control click, open type hierarchy, k-number integer, and the field in k-number integer is called mpz underscore, which we can see in here, mpz underscore. Okay, so there's a base type which is called k-number base, which is a base class which is inherited by two other classes. One is k-number integer, the other one is k-number float. And this computation, this returns different types in the two KDE Git repositories. Okay, let's take this value and debug it more in depth. So for that, I'm going to copy the value which is wrong. So this returns the wrong value here, but the good value in the right-hand side of the screen. For that, I'm copying the value and I'm putting it at the start of the test suite. So here, okay. This is probably of type k-number. Okay. So let's find the same thing in here. So this thing, Control C. Where does it start? In here. Control V. K-number A. Control S. Control S. And let's put a breakpoint after this line. Stop debugging and start debugging again. Locals. So let's see. There's a value and it's already game over because the value underscore is of type k-number integer. Well, it's of type k-number integer here too. Okay, interesting. Let's go back to where we were inside of the test. So there's this set default float precision, which actually sets a global variable, I'm going to guess, inside of this third-party library GNU MPFR. And this might be, I don't know, 0 by default. Is there a get default precision? Yes, there is this thing. Let's see its value. We'll need to know where it's defined. Okay. So the problem is that we did not set the default float precision. So this was probably, I don't know, 0, which meant that numbers, when represented using GMP and MPFR, are of type integer, not of type float. Okay, so let's copy this thing. Control V, Shift delete, Control S. Do the same thing here. Control, where are you? Control S, stop debugging, and start debugging. Okay, let's inspect A again. So locals. And now we have this difference where in the correct KDE Git repository kcalc, the value underscore is of type knumber float, whereas in the wrong repository calc, the value underscore is of type knumber integer. Okay. It's already too late. When the type is wrong, there will be no floating point part, no decimal part. Okay, let's go deeper. So we definitely need to set the floating point default float precision, which we do. But then we'll need to so this part is already different. The computation that's done in the two Git repositories returns different values. So let's look at a smaller part of this math right-hand side. Okay, so let's look at just one. The number A0. This thing. Move the breakpoint such that the value A0 is computed. Control S, start and start. Okay, back to locals, A0, value. So this thing is integer. And this thing is also integer. Okay, so when you construct it with an integer, there's no need for a decimal part, so knumber will actually use its specialization for knumber integer instead of using knumber float. Okay. So the right-hand side, left-hand side are identical. Then what about this thing? Control S, start and start. Back to locals, A0 value a 0 value. Okay, so both values in the right hand side and left hand side are of the correct type, which is key number underscore float. They both have this data member, which is mpfr underscore with the correct type. And there's a difference. So this is identical, this is identical, this is identical. This is certainly not identical. So the precision is different, and it's 1024 in the wrong Git repository, and it's 3323 in the correct Git repository. And we saw that set default float position 1000 actually computes this number 3323. So let's go back there. Stop the debugger. Step into like this. Okay, like that. Start and start. F11 step into, F10. So this bin prec is 3323. F11, this bin prec is computed correctly, still 3323. The correct function which says the global in the SO library is called. Okay, so they're identical in here. But then somehow the member in knumber float is set differently. Okay. So this should totally be 3323 because that's what we set in here. And we determined that set default float precision is important. Okay. And in here it's set to a different value, which is 1024. Okay. Let's see where this 1024 comes from. And exists in just one place. Let's stop the debugger. Okay, the source code at where this const is defined is the same with different spacing and formatting. So const mpfr prec t key number float precision 1024. So this is just defining a constant. It's not actually setting the member variable, the field. So I'm guessing somebody is using this variable. Okay, so the number is already different. So 1 and 1, 1 and 2. It's a member, this class, this const. So this const is actually member of the class and then of the objects of type key number underscore float. Okay, so in the right hand side where it's correct, it just defines the constant, nothing more, and it assigns it a value. Whereas in the left hand side where it's wrong, it actually does use this hard-coded precision value. Okay, let's look at this part of the source code in the correct place. Ctrl Shift F V. So it's just defined in just one place, no overrides. Okay, so line 131 versus line 151. MPFR PTR, key number underscore float, new MPFR, return MPFR underscore, curly brackets, MPFR init2 versus MPFR init, so these two are different. Then MPFR, and then precision. So this one does not specify a precision. So where does the precision come from? It probably comes from that global variable that's set inside MPFR SO file. Okay. And MPFR init2 has an extra parameter compared to MPFR init without a 2. And the second parameter is if you want a different precision that what's set in the global variable inside the MPFR SO. So this is taking the value in the global variable. This is you saying, nah, this time I'll tell you exactly what precision I want. Okay, so basically this is always putting a hard-coded 1024 instead of actually obeying what we tell it to use in the test, where we say set default float precision to that 3323 number. Okay, so let's sync from the correct Git repository towards the wrong Git repository. We're going to sync this method. So this thing should be like this, Control S. Let's directly run the test. And it fails in another place. And this also fails. Why is that? Let's rebuild. Okay, I'm not sure where this thing comes from because it this was actually the fix. Yeah, we changed the source code, so let's revert what we changed. So this thing, okay, this is the problematic part. Let's revert it. Are you? This was just a test, whereas this is the actual fix. The same for Kalk. Okay, we do not need this test. Okay. Yes to all run. Yes to all run. Okay, and now we're successful. Okay, exit status 0 for both KDE Git repositories, Kalk and just Kalk. Okay, so that was the entire fix. Shift delete here, Control S, run it again. Still successful. So the next step is to actually do a git commit. This thing where use the precision set via, what was the name of the function? Set default for precision. Commit. Let's look at the history. So the remote origin master points to this git commit. There's an extra git commit on top of that one, and the local master branch points to that git commit. And we like the changes in the git commit and also the text of the git commit comment. Okay, let's actually test this thing using kdesrc-build. Okay, so we need to run the long command line. So KALK, no src, leave my git commits alone, no include dependencies, refresh build, run tests, and debug. Okay, this is the make, which builds the build artifacts. Then it runs tests in here, where it says running test suit gmail complete result 0. So it doesn't show the rest of the result from the rest of standard output, standard error from make test, but we know that exit status is 0. And then it runs make install. And this is successful too. The build is also successful. We can see it went to 100%. Let's run the application. Where is the division by 2? Okay, it works. And let's run the test ourselves. So that's tilde/kd/build/kkalk, and we run in here make test. And all of the 4 tests are successful, and then we run the test for key number test, which is /bin key number test without any parameters, and it's successful. Okay. And the next step is to actually do a merge request with this. Okay. For that, I'm going to go to my KDE invent user account. I'm going to fork the repository for KALK. I'm going to get the SSH URL to my clone of the KALK Git repository. I'm going to add it in here. Git remote add fork. Then I'm going to paste the Git URL. And then I'm going to create a branch, create new branch, the same name always, work/my username. What does it do? Control V, create, check out this branch. So now it becomes bold. Now the local master branch is bold, is checked out. So we need this one to the new branch, work/nmariuspk number float, set default float precision to be the currently checked out Git branch. I go rescan such that Git GUI now says that current branch is this long branch. And then I go remote, push, and from here I'm selecting the other Git remote, which is fork, not origin, and then push. And then from invent.kd.org, I go refresh the page, and it asks me if I want to create a merge request, which I do. So that's it. And the end result looks like this. The title of the merge request is the comment of the Git commit. The body of the Git commit message is the body of the merge request. And there's just this one change where we replace mpfr init2 with mpfr init. So this is it. We've identified a issue which happens just in the KALK Git repository, but does not happen in the Kalk Git repository, although that part, so the key number test, should be very similar or maybe identical in the two Git repositories. And this also shows us that for many KDE Git repositories, people don't regularly run their tests. So maybe people do not know that they can use kdesrc-build with the parameter run tests, or they do not know about make space tests or ctest. Where is this documented? This is more about how you create unit tests, not the place where it tells you that if you did write unit tests, then keep them always running successfully. Okay, so some of the tests in the test suite of a KDE Git repository are GUI tests, so they spawn graphical user interface widgets, windows, which is a problem. Some are really heavy and ugly tests, such that they go over the internet, try to find various files on the hard disk which do not exist, create all sorts of directory structures, and then they delete them. So maybe that's why people don't regularly run the test suite of the KDE Git repositories. And a good way to help the KDE community is to actually pick a random KDE Git repository, build it using kdesrc-build, and then run its tests and make sure that all of the test suite passes and the exit status is 0. Thank you.